this video, we're going to look at experimental probability. So probability is the likelihood that an event can happen. And experimental probability is actually keeping track of what did happen when you conducted an experiment and then looking at that as a ratio, comparing what you wanted to happen to how many times you conducted the trial to give you its experimental probability. So the probability that actually did occur. So we're going to look at a couple different ways to evaluate experimental probability when you are doing an experiment, like rolling a die, flipping a coin, pulling marbles out of a jar, things like that. We're going to be looking at experimental probability where every event is equally likely. So when you flip a coin, every time you flip it, it doesn't matter what happened previously. So once the data is collected, we can then actually record what did occur during the experiment. So here we have a bar graph that is tracking what happened during our experiment of rolling a number cube. And we can see that our number cube was six-sided and it contained the numbers 1 through 6. And then over here, we can see the frequency, how often each number was rolled. So we can see the number 1 was rolled 10 times. We can see the number 2 was rolled 4 times. We can see that the number 3 was rolled 8 times. The number 4 was rolled 11 times. The number 5 was also rolled 11 times. And the number 6 was rolled 6 times. So in total, we rolled our die 50 times. So when we're looking at probability, we're comparing the probability or what did happen or what we wanted to happen over our total number of trials. How many times did we conduct our experiment? So we want to know the probability that occurred that we rolled an odd number. And so remember, odd numbers would include 1, 3, and 5. So if I'm looking at 1 occurred 10 times, 3 occurred 8 times, and 5 occurred 11 times, I would need to total those up to find out how many times that happened. And I would be comparing that to the 50 times that we actually rolled the die. So 10 plus 8 plus 11 is 29 out of 50. So that would be our probability, or we could put that in percentage form if we wanted to, and we could say that is the same as 58%. But usually we just leave it as a ratio. 29 out of 50 was our probability that we were able to roll an odd number. We can also look at probability for different types of events. So this is tracking how many times it rained. So it rained 2 out of the last 12 days. So we're looking at days that it rained compared to the total number of days that have passed. So we had 2 out of 12. We would actually simplify that to 1 out of 6. And that's what occurred in March. So we want to know if this same trend, the same likelihood occurs, how many days would we expect it to rain in April? So we're going to set up a proportion to solve this. So we have a likelihood of 1 out of 6, and April has a total of 30 days. So we want to know how many of those 30 will it rain. So we're going to solve our proportion using cross products. So we have 6x equals 30. We're going to divide by 6, and we can expect about 5 days of rain during the month of April. Now, we want to compare experimental, keeping track of what did happen, to theoretical. theoretical probability is what we expect to happen. So when we're looking at theoretical probability, we're not actually doing an experiment. What we're actually doing is we're just thinking about what can happen. And that is called our sample space. And we're going to be comparing that to what we want to happen. And that is often referred to as our favorable outcomes. So basically, to find the expected probability, theoretical is our expected, we're comparing our favorable outcomes to what is actually possible. Okay, so we're looking here, and we want to know what we expect to happen based on the blocks that we see. So we can see that we have 7 blocks, and we have an array of letters. And we want to know what is the chance of choosing a vowel. Remember, a vowel are the letters A, E, I, O, and U. So we want to compare how many vowels we see compared to how many total tiles we see. So we see 1, 2, 3 vowels out of 7. So we have a 3 out of 7 expected or theoretical probability of choosing a vowel. Okay, we're going to look at another example of spinning a spinner. And we have a 1 out of 6 chance that when we spin the spinner, we're going to win a bobblehead. And the wheel has 3 bobblehead sections. So we want to know how many sections are on the wheel. So basically the 1 out of 6, that's our simplified probability. We took how many were possible and compared that to how many were favorable. And so we reduced that to 1 out of 6. So we know that we actually see 3 spaces with a bobblehead, and we're going to solve for how many total spaces there are. So we're going to go ahead and do cross products. 1 times x is x. 6 times 3 is 18. So we know that there are 18 spaces on our spinner.